Okay, so to prep beforehand for this lab, you are going to need to make a 750 milliliter solution of 0.025 molar sodium thiosulfate and also another solution of 9 molar sulfuric acid. Once you have those solutions prepped, you are going to need 1 milliliter of manganese sulfate and 1 milliliter of alkaline iodide azide. Also, you are going to need a burette and a beaker, as well as a 100 milliliter volumetric flask with starch indicator. Now that we've got the materials out of the way, let's move on to the procedure. First, open up your water sample and gently dump it into your 100 milliliter volumetric flask. Be sure to be very gentle with this step to not aerate the water and allow more oxygen to get into the water from the outside air. Once you have filled your 100 milliliter volumetric flask, add the 1 milliliter of your manganese sulfate. After that is done, add the 1 milliliter of alkaline iodide azide. After you have added those two solutions, fill up some more of the volumetric flask overflowing with the river water. Then cork the volumetric flask to ensure that no oxygen gets into the water from outside. Once the volumetric flask is corked, pick up the flask and begin to shake it. The brown color forming is the manganese 2+ ions changing to the manganese 4+ ions. Once thoroughly shaken, let the precipitate settle. Once the solution has settled, take off the cork and add 1.5 milliliters of 9 molar sulfuric acid to place the redox reaction under acidic conditions. The new brown color forming in the water is the iodine molecules forming. At the same time, the cloudy manganese 4+ ions are changing back to the manganese 2+ ions. Once the reaction has finished, transfer the solution slowly and carefully into the beaker so again you don't aerate the solution and throw off the dissolved oxygen levels. Before you begin to titrate, add 3 drops of the starch indicator to the solution. Now titrate the sodium thiosulfate solution that you previously made into the water solution. The thiosulfate is going to turn the brown I2 iodine molecules into colorless iodide molecules. Once the solution is fully titrated, record the amount of thiosulfate solution used. You will know when the titration is completely finished when the solution turns completely clear. For the calculations, overall, you wanted to find the amount of dissolved oxygen in the water in ppm. To do this, use the volume of thiosulfate solution used to titrate your sample and find the amount of moles of thiosulfate. After the amount of moles of thiosulfate are found, go from the moles of thiosulfate to the moles of I2 using the mole-to-mole ratios in the balance equations. Then go from the moles of I2 to the moles of Mn4+. From the moles of Mn4+, convert to the moles of MnOOH2. From the moles of MnOOH2, you can finally find the amount of moles of oxygen in the sample. To find the amount of dissolved oxygen in ppm, convert the moles of oxygen to milligrams. Then, put the amount of oxygen in milligrams over the liters of the sample in the volumetric flask. And that is how you use the Winkler method to determine the amount of dissolved oxygen in a given water sample. Thanks for watching.